So following simplification of the model, this was the model of the single-phase transformer. The first simplification involved reflecting the resistance and the reactance of the secondary onto the primary. Hence this phrase here, referred or reflected to the primary side. And we see that in order to do that, we remove the ideal transformer. We multiply the reactance by A square, which is the turns ratio. A is NP divided by NS. And we multiply the resistance of the secondary by A square. So this is the first phase of simplification. What we can do now, we can actually take this simplification further, and we can group this resistor with this resistor, and we can group this reactance with this reactance, and we can move this core or shunt part to one side. So we could actually group RP plus R square AS. So this becomes one resistor, and it has a value of R subscript P plus A square subscript S. And I can group this reactance with this reactance, and I would call it then XP plus A square XS J And then we need to do something with this. So the simplification involves either moving it to this side or either moving it to this side. In this case, I have opted to move it to this side, on the primary side. So we would have here R subscript capital C and XM times J. And then we add all of the other pieces in there. So VP is still here, and AVS is still here. And then we take IP, I subscript primary, and I subscript secondary divided by A. So that's one stage of simplification. Again, we go back and remind ourselves that this is the series part and this is the shunt part. The series part, we'd like it to be as small as possible, and the shunt part, we'd like it to be as large as possible. So this is a phase of simplification. We could actually simplify this further, and we could actually combine this and call it R equivalent. So we could take this to this stage and just say R equivalent, and we use the term X equivalent. And we do away completely with this part. So this is actually simplification, the last stage of simplification, and we end up as well with VP AVS and IPIS divided by A. So if we number these now, so this is actually the model, the first equivalent model. We've done a simplification, or we've removed the ideal transformer, so that's a second simplification. This is a third stage of simplification, and that's a fourth stage of the simplification. And this is really the most simple model. We've just actually taken the series component, we've kept the series component, we've done away with the shunt component as a simplification, and we know that R equivalent is equal to R primary plus A square R secondary, and X equivalent is equal to X primary plus A square X secondary. But I have to stress again that all of this is actually referred to the primary side. So all of these models, whether this or this or this model or this model, all of them are referred to the primary side. So this is what you would see when looking at the transformer from the primary side.